Question 1. Find the greatest common factor of 3 and 12. Well, the factors of 3 are 1 and 3. The factors of 12 are 1, 2, 3, 4, 6, 12, and so on. But the greatest common factor between the two of them, greatest common factor, is 3. Question B. What is the greatest common factor of 2x squared and 4x? Now, because both of these terms have an x variable, we can break this down into two parts. We'll start by finding out what is the greatest common factor between 2 and 4. So the factors of 2 are 1 and 2, and the factors of 4 are 1, 2, and 4. So the greatest common factor between the two of them is 2. So it's going to be some sort of 2 that's going to be our greatest common factor. Now we look at the variables. We've got x squared and we have x. The least of the two variables is x. So we will say that our greatest common factor is 2x. Question C, 5x squared and 30x squared. 5x and 30x squared. So let's look at just the number values first. So the greatest common factor between 5 and 30 is 5. And the smallest of the variables between x and x squared is x. So we'll say that our greatest common factor is 5x. Factor the following. 3x squared minus 42. Greatest common factor is 3. We put down our 3. Divide 3x by 3 and we get x. We divide 42 by 3, we get 14. And we will use the similar sort of process for the rest. Our greatest common factor for b would be 4x. So we write in 4x outside the brackets and divide 4x squared by 4x and 16x by 4x, and we get x plus 4. C, our greatest common factor, is 3. Divide all the terms by 3, and we get 3 bracket x squared plus 3x minus 1. Now in question 3, they've asked us to expand each of our answers here. So by expanding each of our answers, for example, by expanding 3 bracket x minus 14, we should arrive back at 3x minus 42. And this will be the case for each one of these questions, A, B, and C. So, sure enough, this expanded equals 3x minus 42, which is the same as our starting value here. This one becomes the same as our starting value here, and our answer here becomes the same as our starting value here. Factor each of the following by a common factor. Well, the common factor here is 5. The common factor here is 3x. The common factor here is 6. And the common factor here is 7. The common factor here is 4. The common factor here is 2. The common factor here is -2. And the common factor here is 2. Question 5 tells us you can also have a binomial as a greatest common factor. So we look at these two terms. Both of them can be evenly divided by x minus 4. So the pattern here is we just write down our common factor, x minus 4, and then we add our values from here. So our common factor is x minus 4, and the values beside the brackets are x plus 2. So this becomes our factored form. Here, our common value, or common factor, is 3x minus 4. 3x minus 4 gets written here, and we simply add our 2 plus 7 as our other factor. Once again, this is just a pattern that we need to get used to. Find the dimensions of each rectangle by factoring. Our common factor here is 5x. So if we want to know the dimensions, we're looking for something times something. We're looking for length times width. So by factoring this by our common factor, we get 5x, 3x minus 1. This becomes our length. This is our width. Here, we're given another rectangle where the area is 6x squared plus 36x. Once again, by factoring it, we get something times something, length times width. So when we factor this by the greatest common factor, which happens to be 6x, we get 6x times x plus 6. The larger value, 6x, becomes our length. The smaller value becomes our width. And we can draw these diagrams here just to represent what our length and what our width are. And over here, 6x is our length, x plus 6 is our width. Now we're told that x has a value of 2. So we can simply plug in that 2 wherever x is to figure out what our length and width is for this rectangle, 5 and 10, and plug it in over here to find out what our dimensions are for this rectangle. There's our width and there's our length.